Hi everybody, I'm Number Gazer. Today I would like to talk about an equation in epidemiology which might be useful. It's about deriving the incidence of an irreversible disease without performing lengthy follow-up studies. What I typically do to estimate the incidence rate of an irreversible disease, you set up a cohort of persons who are initially disease-free. Every now and then, the members of the cohort are examined if someone contracted the disease. There are a variety of drawbacks in performing such a follow-up study. First, follow-up examinations may be expensive. Second, in rare diseases, many persons have to be recruited and observed for a long time period. Third, in sexually transmitted diseases, for example, persons who fell ill might feel stigmatized and will not return to the follow-up appointments. This can easily impose a systematic error. Those practical difficulties lead to situations when surveys are not performed, especially in the developing countries. Compared to costly follow-up studies, cross-sectional studies are available more often. In a cross-section, the proportion of persons in a population who have the disease is estimated. This proportion is called the prevalence. Consider a population where the prevalence is 10%. Assume at some later point in time this number increases to 12.6%. The question arises, what can be learned from this about the incidence? So don't get afraid of this weird-looking equation which links the prevalence with the incidence. The equation will be explained in the following. What do the symbols in this equation mean? We want to say something about the temporal change of the prevalence. So we need time t. We need the prevalence p. And the temporal change of the prevalence. Of course, we need the incidence rate I. Furthermore, we need two mortality rates. M1 is the mortality rate of the diseased persons and M0 is the mortality rate of the persons without the disease. This looks weird, so I want to explain this by an analogy. Think of a crowded swimming pool on a hot summer's day. Sometimes swimming pools are divided into two parts. One part for those who swim and another part for those who don't. An analogy for the prevalence is the number of persons in the non-swimmers part over the total number of persons in the pool. The incidence is the rate at which persons from the swimmers part of the pool enter the non-swimmers part. Since we are dealing with irreversible diseases, the way back to the swimmers part is not allowed. The rate at which swimmers leave the pool is m0. The rate of the non-swimmers leaving the pool is m1. Now in an example, we'll put some numbers into the game. For simplicity, we need that no one enters the pool. And as in the beginning of this talk, we consider 2 points in time. At time t, let's assume that exactly 900 swimmers and 100 non-swimmers are in the pool. This means at time t, the prevalence is 10%. Furthermore, assume that the incidence is 0.03, m0 is 0.01, and m1 is 0.02. This means from those 900 swimmers, 9 get out of the water and 27 enter the non-swimmers part. In the non-swimmers, 2 get out of the water and 27 swimmers enter. Thus, at time t plus 1, we have 864 swimmers and 125 non-swimmers. This implies that the prevalence increases to 12.6%. The change of the prevalence between both points in time is 12.6% minus 10%, which equals 2.6%. Now, as we know that the change is 2.6%, let's have a look at the other side of the equation. Do you still remember? The other side of the equation was looking like this. If we put in the numbers, we exactly find those 2.6%. It's always nice when math is doing its job. Now we go back to the problem of deriving the incidence from prevalence at 2 points in time. Let's change the example such that we don't know what the value of the incidence is. With some algebra, we can solve the equation for the incidence. As we have observed the 2.6% change in the prevalence, we can fill in the numbers and find that the incidence equals 0.03. This is exactly the value we have used for setting the example up. For further applications, it may be valuable to get information about the incidence from only one cross-sectional survey. This works fine if several age groups are sampled. In this case, age plays the role of the time variable.